Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Electrochemistry. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that which of the following electrolytic solutions has the least specific conductance. So the rule is that the specific conductance of an electrolytic solution solution, now that is inversely proportional to the concentration of the electrolyte concentration of the electrolyte. Simply it means that the molar conductivity m- molar conductivity or the specific conductance, that is inversely proportional to the concentration of the electrolyte. So if the concentration is low, or with increase in the dilution, or with increase in dilution, the specific conductance will increase, or the molar conductivity will increase. So the here it is asked to find that electrolytic solution which has the least specific conductance. So the specific conductance will be least if the concentration is the highest. So the highest concentration is 2 normal, which is in option A. So in option A only, the concentration is the highest, so its specific conductance will be the least. So option A is the correct answer. Then here it is told the standard electrode potential for the half cell reactions are. So Zn2 plus 2 electrons gives zinc Zn, where the E naught cell, so here E naught for Zn2 plus 2 Zn, E naught Zn2 plus 2 Zn, that is equal to, which is the, so here they have told the reduction potentials. The reduction potentials have been told, the standard reduction potentials. E naught means standard reduction potential. So here the standard reduction potential for Zn2 plus to Zn, that is minus 0.76 volts, and here also E naught for Fe2 plus 2 Fe, that is given as minus 0.44 volts. Then the EMF of the cell reaction is, so here Fe2 plus Zn is going to Zn2 plus Fe. So here Fe is getting reduced, but zinc is getting oxidized. So here the E naught cell, the EMF of the cell, that is equals to the E naught from for Fe2 plus 2 Fe minus, it will be E naught Zn2 plus 2 Zn. So it is the reduction potential at the cathode minus the reduction potential at the anode. So therefore this will be equal to minus 0.44 minus of minus 0.76. So that is 0.76 minus 0.44 volts, that is equal to 0.32 volts, and which will be plus 0.32 volts. So option C is the correct answer. And here it is told that in the electrolysis of acidulated water, it is desired to obtain 1.12 cubic centimeter of hydrogen per second under STP condition. The current to be passed is so as you know that at STP the molar volume of any ideal gas of a gas, that will be equal to 22.4 liters, or I can tell it is 22,400 milliliters, or I can tell in centimeter cube there is. Since here the volume of the hydrogen gas that is being told, that is 1.12 cc means centimeter cube. So therefore the number of moles of hydrogen that will be obtained per second, the number of moles of hydrogen obtained per second, the number of moles of hydrogen obtained per second, that will be equal to 1.12 centimeter cube divided by 22,400 centimeter cube. So this will be 1.12 divided by 22400 moles. Now this is equal to, so this is 112 into 10 power minus 2, I can tell. So 112 into 2, this is, so this is 1 by 2 into 10 power minus 4 moles. And therefore the number of equivalents, of hydrogen, that will be equal to 2 into the number of moles, that is 10 half into 10 power minus 4, so that is 10 power minus 4 equivalents. Since why, as we know that the valency factor for hydrogen will be 2 only for H2, since 2 moles of hydrogen, since H2 will um, so 2 H plus ions will gain 2 electrons to form one molecule of H2. So it means that the valency factor for hydrogen is 2 here, since it will gain 2 electrons, since 2 electrons are involved here. And as we know that the number of equivalents, that is equal to the valency factor times the number of moles. So the rule is that one equivalent of one equivalent of the gas requires 1 Faraday charge. 1 Faraday charge. So now here, so 10 power minus 4 equivalents of hydrogen gas requires 10 power minus 4 Faraday charge, where 1 Faraday equals to 96500 coulombs. So 1 Faraday charge equals to 96,500 coulombs. So now therefore 10 power minus 4 equivalents of hydrogen gas is obtained per second, is to be obtained per second. So therefore the current required current required will be the amount of charge that is required, is 10 power minus 4 into 96500 coulomb by 1 second. Since why this much amount of charge is required per second, so this will be 9.65 ampere, since coulomb per second means ampere. Okay. 9.65 ampere. So option A is the correct answer. Then here it is told that the one which decreases with dilution is. So when the dilution is increased, then it means the concentration decreases. Concentration decreases. So then, and when concentration decreases, yeah. So when dilution increases, the concentration of the ions decreases. It means the number of ions per unit volume decreases, and so it means the specific conductance will decrease. So the specific conductance will decrease. So option B is the correct answer. Then here it is told 9.65 coulomb of electric current is passed through fused anhydrous magnesium chloride. So 9.65 coulomb of electric current is passed through fused anhydrous magnesium chloride MgCl2. The magnesium metal is obtained. Since Mg2 plus ion will gain 2 electrons to form magnesium metal. So the magnesium metal obtained is completely converted into a Grignard reagent. The number of moles of the Grignard reagent obtained is. So Grignard reagent that is given as RMGX, where R is some alkyl group and X is some halogen. So here so here we know that the weight of the magnesium m- m- metal that will be obtained, weight of the magnesium m- metal that will be obtained. So that is given as W equals to Z into I into T, ZIT. Where I is the current which flows and T is the time interval in which it flows. So I into T, I can take it as the charge Q. Now, and Z is equals to the equivalent weight divided by 1 Faraday charge. Okay. So the equivalent weight of magnesium, that will be 12 divided by 1 Faraday, that is 96500. So therefore the weight of the m- magnesium that will be obtained, that will be equal to Z into Q, Z into Q. So here Q is given as 9.65 coulomb. So it will be 12 by 96500 into 9.65. So this will be 12 into 965 into 10 power minus 2 divided by 965 into 10 power 2. So this will be 12 into 10 power minus 4 gram. Will be to 10 power minus 4 gram. So the number of moles of magnesium obtained will be same as the number of moles of Grignard reagent that will be obtained. So here the thing is that since 1 mole of Grignard reagent will contain 1 mole of Mg also. So therefore the number of moles of magnesium obtained, that will be same as the number of moles of Grignard reagent that is obtained. So therefore the number of moles of magnesium that will be obtained, that will be equal to the weight of magnesium that is obtained divided by the molar mass, which is 24. So here we saw that so since here uh, the valency factor for magnesium is 2, since why it will gain 2 electrons, 1 mole of magnesium will gain 2 mole of e- electrons. So the valency factor for magnesium is 2 only, and the equivalent weight of magnesium, that will be given as the molecular weight divided by the valency factor. So the molecular weight of magnesium is 24 divided by the valence factor 2, so it is 12. So we have used 12 here. So the number of moles of magnesium, that will be the weight of magnesium obtained divided by 24. So that is weight obtained, that is 12 into 10 power minus 4 gram divided by 24. So this will be 0.5 into 10 power minus 4 moles, or I can tell 5 into 10 power minus 5 mole. 5 into 10 power minus 5 moles. So option C is the correct answer. Then here it is told that the standard EMF of galvanic cell involving 3 moles of electrons. The standard EMF of a galvanic cell, which is E naught cell, that is being asked, involving 3 moles of electrons in its redox reaction is 0.59 volts. The equilibrium constant for the reaction of the cell is the equilibrium constant K for the reaction that is being asked, K. So as we know that NF E naught cell, NF E naught cell, that is equal to 2.303 RT log K. So the K has been asked. The equilibrium constant K has been asked here. So here, so therefore E naught cell, that is equals to 2.303 RT by NF into log K. Now this 2.303 RT by F, if it is so if it is at room temperature, then 2.603 RT by F, 2.303 R into T by F, that is approximately equal to 0.059. So this will be 0.059 divided by N into log K. So here the number of moles of the electrons that is involved, that is 3 here. So therefore now E naught cell, that is given as 0.59. So 0.59 equals to 0.059 by N. N is 3 into log K. So we have to find out K. So therefore log K, that will be equal to 3 into 0.59 means 59 into 10 power minus 2 divided by this is 0.059. So 59 into 10 power minus 3. So this will be 30. So log K will be equal to 30. So therefore K, the value of K will be approximately equal to 10 power 30. 10 power 30 is the equilibrium constant of the reaction. So option D is the correct answer. Then here it is told E1, E2, E3 are the EMFs of the following 3 galvanic cells respectively, and which one of the following is true? Z, Zn goes to Zn2 plus and Cu2 plus goes to Cu. So here, as you know, that E cell equals to E naught cell minus 0.059 by N into log this will be the concentration of this Zn2 plus divided by Cu2 plus. Since here the equilibrium constant Kc, that will be equal to concentration of Cu2 plus divided by concentration, no, the concentration of Zn2 plus by concentration of Cu2 plus. Since why? Since here the reaction is Zn plus Cu2 plus, that gives Zn2 plus plus Cu. So, so it means that, and this is solid, so we should not consider them in the equilibrium constant. So it should be the concentration of Zn2 plus by concentration of Cu2 plus. So now, E naught cell is the the standard reduction potential at the cathode, minus or plus the standard oxidation potential at the anode. So here the cathode, here at the cathode, the Cu2 plus ion is getting reduced to Cu by gaining 2 electrons, and here at the anode the Zn is being oxidized to Zn2 plus by losing 2 electrons. So therefore here E naught cell, that is actually E naught reduction at the cathode, means E naught, we have to do Cu2 plus to Cu and plus E naught oxidation at the anode, means we have to do plus E naught Zn2 plus. Now we know that the the reduction potential at this cathode, which is E naught Cu2 plus to Cu, that is approximately 0.35 volts, and the E naught oxidation potential from Zn to Zn2 plus, that is equal to 0.76 volt. So therefore, E naught cell, that will be equal to 0.35 plus 0.76, that will be equal to 1.11 volts. So therefore, here the EMF of the cell, the EMF of the cell, E cell, that is equal to 1.11 minus 0.059 by N, and here N will be 2 only, since here 2 moles of electrons will be involved here. 2 moles of electrons will be involved. So here this N will be equal to 2. So 0.59 by 2 into log of concentration of Zn2 plus by concentration of Cu2 plus. Now here, so I can say E1. E1 is the inert cell for the first case. So that will be 1.11 minus 0.059 by 2 into log of Zn2 plus concentration, that is 0.1 by 1. So this will be minus 1. So this will be plus 1. So 1.11 plus 0.059 by 2. And then E2 will be 1.11 minus 0.059 by 2 into log of concentration of Zn2 plus is 1, concentration of Cu2 plus is also 1, log 1 by 1, that is 0. So it is 1.11 only, 1.11 volt. And this is this much volt, slightly more than 1.11. And E3 is 1.11 minus 0.059 by 2 into log of concentration of Zn2 plus here, that is 1, by concentration of Cu2 plus, that is 0.1. So this will become log 10, which is 1. So this is 1.11 minus 0.059 by 2 volts. So it means if you have to arrange the EMF in the descending order, then it means therefore the highest value will be E1 greater than E2 greater than E3. So E1 greater than E2 greater than E3. So option B is the correct answer. Then here it is told the standard EMF of a galvanic cell involving 2 moles of electrons in its redox re reaction. The standard EMF, which is E naught cell, that is given as 0.59 volts, and in the redox reaction it involves 2 moles of electrons, so N is equal to 2 only. Now the equilibrium constant for the redox reaction of the cell is, now as we know that NF E cell, NF E naught cell, that is equals to 2.303 RT log K. So we have to find the equilibrium constant K of the redox reaction of the cell. So therefore we can say that E naught cell, that is equals to 2.303 RT by NF log K. Now 2.303 RT by F, that is 0.059 at room temperature. It means at T equal to 298 Kelvin, the value of 2.303 RT by F, that is approximately 0.0591 or 0.059 also you can take. So therefore E naught cell, that is 0.59 volts, that is equal to 0.059 by N is 2 into log K. So therefore log K, that will be equal to, this will be 59 into 10 power minus 2 into 2 divided by 59 into, this is 10 power minus 3. So 59 will cancel out. So log K, that is equal to 2 into 10, that is equal to 20. So K will be approximately equal to 10 power 20. So 10 power 20 is the equilibrium constant. So option A is the correct answer. Then it is told the approximate time duration in hours to electroplate. The approximate time duration in hours to electroplate 30 gram, means the time has been asked to electroplate 30 gram of calcium from molten calcium chloride molten calcium chloride CaCl2 using a current I having of 1 amperes. Then it is told that the atomic mass of calcium is 40. So now, therefore, as we know that the weight of calcium that will be deposited at the cathode, the weight of calcium that will be uh, deposited at the cathode, that will be equal to ZIT, Z into I into T. Now this T has been asked, the time in hours we have to find out. So the weight of calcium, that is 30, and Z is equals to the equivalent weight divided by 1 Faraday F. Now the equivalent weight of calcium that will be equal to the atomic weight or atomic mass of calcium divided by its valency factor. Now calcium chloride Ca is in Ca2 plus state, so it should gain 2 electrons to form C calcium atom. So since it will gain 2 moles of electrons to form 1 mole of calcium, so the valency factor for calcium will be 2 here. So therefore the equivalent weight of calcium will be 40 by 2, that is equal to 20 gram. So this will be equal to, so Z will be equal to 20 by F. F is 96500. So this will be 20 by 96500 into I, current is 5 ampere, into T. T has been asked. So therefore T will be equal to 5 into 2, that is 100. So this will cancel. So T will be equal to 965 into 30, this much seconds. So we have to find the time in hours. So that is approximately 965 into 30 divided by 1 hour is 3600 seconds. So this much hours it will take. So 0 will cancel, 3, 120, 12. So this is 96.5 by 12 hours. So it is approximately 12 8s are 96, and 0, 12 4s are 48, 12 4s are 48. So approximately 8.04 hours. So which is approximately 8 hours. So option A is the correct answer. Then the equilibrium constant for the reaction is. So here also A solid plus 2B plus ion in the aqueous state. It is a reversible reaction. It forms A2 plus ion in the aqueous state plus 2B solid. So therefore here the equilibrium constant K, that will be equal to obviously the concentration of A2 plus divided by the concentration of B plus whole square. Now that has been asked. Now as you know that E naught cell that is equal to 2.303 RT by NF into log K. Now E naught cell that is given as 0.0295 volts, and we know that at room temperature the value of 2.303 RT by F, that is equals to 0.059. And here, since here A has to lose 2 electrons to form A2 plus ion, and 2B plus will gain 2 electrons to form 2B, 2 atoms of B. So here N is equal to 2, since 2 moles of electrons is used. So therefore E naught cell, that is 0.0295, is equal to 0.059 divided by 2 into log K. Now this value is 0, 2 to the 4. So now 59 by 2, that is 2 to the 4, 0.059 by 2, that value will be 0.02 to the 4, 2 9 is 18, 2 5 is 10. So 0.0295. So these two will get cancelled. So log k is equal to 1. Log k is equal to 1 means k is equal to 10. The equilibrium constant of the reaction is 10. So option A is the correct answer. And here it is told which one of the following has a potential more than 0. Which one has a potential more than 0? Now here now if I take E cell is 0, then we can say mm, so here E naught cell will be 0 only. E naught cell will be 0. So now here E cell will be actually equal to minus 0.059 by n. Here n will be 1 only, since half mole of H2 will be formed from one H plus ion, which has to gain 1 mole of electron to form half mole of H2, and 1 mole of HCl here also. So only 1 mole of electron is involved here. So n is equal to so n is equal to 1. So 0.059 by 1 log of the pressure of H2 divided by the concentration of H plus, and it means the concentration of HCl. So therefore for the option A, E cell will be equal to 0 only, since why pH2 is also 1 atmosphere and H plus concentration is also 1 molar. So log of 1 is 0. So it is 0 volts. And option B, this one is E cell, that will be equal to 0.059 by 1 into log of 1 by 2, since the concentration of H plus here is 2 molar. 2 molar, so log half. So this we can write 0.059 into log 2 plus. Okay. And C, so for option B only, the E cell is more than 0, means the electrode potential is more than 0 here. And in option C, we can see that E cell will be minus 0.059 by 1 into log of concentration, no, log of the pressure of H2, that is 1 atmosphere, by concentration of HCl, that is 0.1 molar, 0.1. So this will be log 10, that is 1. So it is minus 0.059 volt, which is less than 0. And in option D also, E cell will be minus 0.059 by 1 into log of the pressure of H2 is 1 and concentration of HCl is 0.5. So it is also log 2. So it is minus 0.059 into log 2 volts, which is obviously less than 0. So only for the option B, the electrode potential is more than 0. So option B is the correct answer. Now here it is told the EMF of a galvanic cell constituted with the electrodes Zn2 plus to Zn. Now E naught Zn2 plus to Zn is given as minus 0.76 volts, and E naught Fe2 plus to Fe, this is minus 0.41 volts. So the EMF of the galvanic cell, so here no, E naught cell, that is equals to So that will be now be E naught Fe2 plus 2 Fe minus E naught Zn2 plus 2 Zn. Since why here the reduction potential is higher, so Fe2 plus will be reduced to Fe and Zn will be oxidized to Zn2 plus. Or simply you can say E naught cell is E naught the electrode potential of the right hand e- e- electrode minus E naught of the left hand electrode. So here the electrode on the left hand side is Zn2 plus 2 Zn. This one is left hand electrode, and the right hand electrode is Fe2 plus 2 Fe. So this is right hand electrode. So this will be E naught Fe2 plus 2 Fe, that is 0 minus 0.41 volts minus the electrode potential of Zn2 plus 2 Zn, that is minus 0.76 volts. So this will be 0.76 minus 0.41 volts. So that is equal to 0.35 volts plus. So option C is the correct answer. Then here it is told for Cr2O7, Cr2O7 2 minus plus 14H plus 6 electron gives 2 Cr3 plus 7 H2O. So here E naught cell, here E naught cell that is given as 1.33 volts, and then add if the concentration of Cr2O7 2 minus is 4.5 millimoles, means 4.5 into 10 power minus 3 moles, and the concentration of Cr3 plus is 15 millimoles, means 15 into 10 power minus 3 moles, then the EMF of the cell, that then E cell, is 1.067 volts, then the pH of the solution is nearly equal to. So then we have to find the pH of the solution. So now pH, as you know, that is minus of log of concentration of H plus R. So now here we can use that E cell, that is equals to E naught cell minus 0.059 by N into log of K, where K is the equilibrium constant. So here the equilibrium constant K, that will be equal to here the concentration of Cr3 plus whole square into the concentration of H2O whole power 7. Now since H2O is a liquid, so we don't have to we can take the concentration of H2 as 1 only, so we don't have to take that in the equilibrium constant. Now, so that is concentration of Cr3 plus whole square by concentration of H plus whole power 14 into concentration of Cr2O7 2 minus. And here n is the number of moles of electrons that is used, that will be equal to 6. N is equal to 6. N is equal to 6. So therefore we can say that E cell, that is 1.067, that is equal to 1.33 minus 0.059 by 6 into log of concentration of Cr3 plus, that is 15. So that is 15 into 10 power minus 3 whole square divided by the concentration of H plus ion whole square whole power 14 into the concentration of the Cr2O7 2 minus, that is 4.5 into 10 power minus 3 Okay, 4.5 into 10 power minus 3. So therefore you can say that this, if we subtract, then we will get, so 1.067 minus 1.33, this will be equal to into, okay, so this will be equal to minus 0.059 by 6 into, this will be log of this. So now this we can write 2 into log of 15 into 10 power minus 3, then minus m- minus 14 into log of h plus, and m- m- minus log of 4.5 into 10 power minus 3. Okay. So this will be equal to, mm, this will be 6 into, this will be 6 into 2 point, sorry, this is 0.263, 2.263 by 0.059, that is equal to 2 into log 2 into log 15 into 10 power minus 3. It means that it is uh, log 15 minus 3. Then this is plus 14 pH. Since minus log of h plus, we can write it as pH. And minus this will be log of 4.5 minus 3. 4.5 means I can, okay. So this will be 15 3s are 45. Okay, okay. So this will be, now this value will be 6 into 263. 6 into 263 by 59. That is equal to 2 into log 15 minus 3. Log 15, that is log 3 plus log 5. Log 3 plus log 5, okay, minus 3 plus 14 pH, and this will be 4.5. So 15 3s are 45. So this is 2 log 3 and 5 9s are 45. So plus log 5 minus 1 minus 3, since we can write it log 45 by 10. So it is log 45 minus log 10. So log 10 is 1, so I should subtract 1. And log 45 means 5 into 3 square. So it is log 5 plus 2 log 3 minus 3. So this 2 log 3 and 2 log 3 will get cancelled. And this is, so this is 6 into 263 by 59. So that is equal to 2 log 5 minus log 5, that is log 5, and minus 6, then plus 6, no, minus 6 and plus 4. So that is minus 2 plus 14 pH. Therefore, 14 pH, that is equal to, now 6 into 263 divided by 6 into 263 divided by 59. So that is 26.75 approx. 26.75. That will be then plus 2 minus log 5. Log 5 is 0.7. So pH value will be to be 28.75 minus 0.7. So this will be 28.05 divided, okay, divided by 14. So it is approximately equal to 2. Approximately 2. So the pH value of the solution is nearly 2. So option A is the correct answer. So here it is told that impure copper. So here we have a sample of impure copper. So it contains iron, gold, silver as the impurities, and it is electrolytically refined, and uh, a current of 140 ampere for 482.5 seconds is flown through it, so that it decreases the mass of the anode by 22.26 gram. So the mass of anode decreases by 22.26 gram, and the mass of cathode increases by 22.011 gram. Then the percentage of impure copper is the percentage of impure copper is, or the percentage of iron in the impure copper is, that you have to find out. So here it means the net charge which has flown through it, that is Q equals to I into T, it is equal to 140 into 482.5 coulomb. So that will be equal to 67550 coulomb. So this much amount of charge has flown through the impure copper. Then therefore now the mass of copper that will be deposited, mass of copper that will be deposited at the cathode, so that will be equal to W, that is equal to Zi into T, or Z into Q, I can say. Here the charge Q is, here the charge Q is 67550 coulomb, and Z is equal to the equivalent weight of copper, which is 63.54 divided by 2 into 1 by F, which is 96500. Since Y here at the cathode, copper will change into, means Cu2 plus ion will gain 2 electrons to form copper atoms, and Fe2 plus also will gain 2 electrons to form Fe atoms. So the valency factor for copper is also 2, and valency factor for iron is also 2. And as we know that the equivalent weight that is given as the molar mass of copper divided by the valency factor. Okay. So here The equivalent weight, that is 31.77 divided by 96500. So Z into Q. So the weight of copper that will be deposited at the cathode, that will be 31.77 divided by 96500 into 67550, and that will be equal to 22.239 gram. But here it is told that the mass of copper, that is the mass increase in the cathode, is 22.011 gram. So therefore the extra amount of the impurities, the the amount of the impurities, or the amount of the impure copper, that is equal to 22.239 uh, minus 22.011 gram, that is equal to 0.228 gram. Now we know that the weight of, now here the number of equivalents of iron, that is same as the number of equivalents of copper, so the weight of copper divided by the equivalent weight of copper, that is equal to the weight of the iron divided by the equivalent weight of iron. So now therefore the weight of copper, that is 0.228 gram, divided by the equivalent weight of copper, that is 31.77, that is equal to the weight of the iron divided by the equivalent weight of iron, that will be also 55.5 divided by 2. So therefore the weight of the iron, that is equal to 55.5 by 2 into 0.228 divided by 31.77. So if we solve it, then we'll get 0.199 gram of iron. So it means that and so it means that 0.199 gram of iron is present in is present in okay, 0.199 gram of iron is present in 22.26 gram of the impure copper sample, in 22.26 gram of the impure copper sample. So therefore the percentage of copper, the percentage of copper in the sample, that will be equal to 0.199 divided by 22.26 into 100%. So that will be equal to, so that will be approximately equal to 0.9%. So it means that option D is the correct answer. Then here it is told, for hydrogen oxygen fuel cell at 1 atmosphere and 298 Kelvin, the E naught for the cell is approximately. Now as we know that delta G naught, that is equal to minus NF E naught cell. Therefore E naught cell, that is equals to delta G naught by minus NF, minus delta G naught by NF. So this will be equal to minus delta G naught will be 240 kilojoules. So 240 into 10 power 3 joule divided by N. So here H2 will gain two elect oh, no, it will lose two electrons to form two H plus ends, and one oxygen atom will gain one electron or gain two electrons to form O2 minus N. So it means the valency factor for H2O is 2 here, and the also the number of moles of electrons used here, that is also 2. So N is 2 here, into F is 96500. So from here we can get the E naught cell. So if we solve it, then we will get 240. So this is 120 by 96.5 into 10 power 3, and 10 by 10 power 3, that will cancel out. So 120 by 96.5, which is approximately equal to 1.24 volts. So option B is the correct answer. When it is told how many coulombs of electricity are required, how many coulombs of electricity are required for the oxidation of 1 mole of water to dioxygen? For the oxidation of 1 mole of water, so we have H2O. H2O will go to, it will be oxidized to 1 mole of to dioxygen, so it will form half O2 plus H2. So here H2H plus should gain 2 electrons to form H2, and the oxide ion should lose 2 electrons to form half O2. So it means that 2 moles of electrons is required. So it means that 2 Faraday charge is required. 2 2 Faraday charge is required. So it means therefore the net charge required, net charge Q required, that is equals to 2F, which is 2 into 96500 coulombs. Since 1 Faraday equal to 96500 coulombs. So this will be equal to 2 5s are 10. You can say 96.5 into 2 into 10 power 3 coulombs. So this will be 2 is a 10, 2 is a 12, 13, 2 9 is a 18. So 193 into 10 power 3, or I can say 1.93 into 10 power 5 coulomb. So option D is the correct answer. Then here it is told, while charging the lead storage battery, so in the lead storage battery, what happens? So we know that at the anode there is always oxidation. There is oxidation, and at the cathode there is reduction. There is reduction. So it means that um, C and D is wrong. Since why, and in the option C it is told at anode there is reduction, and in option D it is told that on cathode there is oxidation, which is wrong. So out of A and B we have to think which one is correct. So here PbSO4 P, PbSO4 will be reduced to lead, since here the Pb2 plus ion will gain 2 electrons to form lead at the cathode, and plus the sulfate ion will be there, and so it means that at the cathode Okay. And at the anode, there is at the anode there is oxidation, means at the anode PbS4 will be oxidized to PbO2. It will lose 2 electrons at the anode. At the anode PbSO4 okay. So it means that while charging, the opposite reaction will happen. It means that while discharging or while in the use, these two reactions will happen, and while charging, the opposite reactions will happen. It means that at the anode, the PbSO4 will be reduced to lead, and at the cathode, the PbSO4 will be oxidized to P, PbO2. So it means the opposite reaction will happen when there is charging. So it means that option C is the correct answer. So at the anode only, this PbSO4 will be re- reduced to lead. Okay. Then here it is told in H2O2 fuel cell, the reaction occurring at the cathode is. So in H2O2 fuel cell, at the anode, there the hydrogen will be oxidized to H2O. So 2H2 plus 4OH minus, that will form 4H2O plus 4 electrons. So the 4 hydrogen atoms will lose 4 electrons, and at the cathode there will be reduction, is the oxygen will be reduced to hydroxide ions. So to O2 plus 2H2O plus 4 electrons, that will give 4 OH minus ions. So therefore here the overall cell reaction, that is 2H2 plus O2, that gives 4H2O, that gives 2H2O. So the reaction occurring at the cathode is O2 plus 2H2O plus 4 electron gives 4 hydroxide ions. So option A is the correct answer. Then which of the following is incorrect in a galvanic cell? So oxidation occurs at the anode, which is true, and reduction occurs at the cathode. Now reduction means gain of electrons, gain of electrons, and oxidation means loss of electrons. So the electrode at which electrons are gained is called cathode. Since so here there is reduction which will happen at the cathode, and oxidation, which means loss of electrons, that will happen at the anode. So it means that option D is the wrong statement. So option D is the correct answer. Since why here it is told the electrode at which electrons are lost is called cathode, which is wrong. Since why it has to be anode. Then it is told secondary cell is one which, the secondary cell means it is a rechargeable cell. Secondary cell means rechargeable cell. So a secondary cell is one which can be recharged by passing current through it in the opposite direction. So if current is passed through it in the opposite direction, then it can be recharged. So option C is the correct answer. Then the amount of current in Faraday required for the reduction of 1 mole of Cr2O7 means dichromate ions to Cr3 plus ions is, so here Cr2O7 2 minus, it will mm, gain 14 H plus ions plus 6 electrons to form 2 Cr3 plus ions and 7 H2O. So here we have to balance the ionic equation. We have to balance this ionic equation in the acidic medium. In the acidic medium, since why in the acidic medium only Cr6 plus ion, here the Cr2O7 minus ion will be reduced to Cr3 plus ion. Since here the oxidation state of chromium is 6 plus. So here 1 mole of Cr2O7 2 minus ions requires 6 mole of electrons. So it means that 6 Faraday charge is required. 6 Faraday charge is required. So option C is the correct answer. Option C is the correct answer. Then here it is told that by passing electric current, NaClO3 is converted into NaClO4 according to the following equation. How many moles of NaClO4 will be formed when 3 Faradays of charge is passed through NaClO3? So here NaClO3 plus H2O. So here in NaClO3, the oxidation state of chlorine is 3 to the 6, 6 minus 1, that is plus 5. And in NaClO4, the oxidation state of chlorine is 4 to the 8 minus 1, so it is plus 7. So it means that when NaClO3 will change into NaClO4, it will lose 2 electrons. So there is oxidation. See, NaClO3 is oxidized to NaClO4 and 2 electrons is being lost here. Uh, so it means that uh, 2 Faraday charge or 2 moles of electrons is required to oxidize 1 mole of NaClO3 to 1 mole of NaClO4. So it means that 2 Faraday charge is required is required to form 1 mole of NaClO4. So 1 Faraday is required to form half mole of NaClO4. So it means that 3 Faraday charge is required to form 3 by 2 moles of NaClO4. So 3 by 2 moles of NaClO4 will be formed. 3 by 2 means 1.5 mole. So option C is the correct answer. Then here it is told, in the electrolysis of aqueous sodium chloride solution, which of the half cell reaction will occur at the anode? So the rule is that during the electrolysis of aqueous of aqueous sodium chloride solution, the oxidation reactions which can happen, or the possible oxidation reactions are: one is the chloride ion can be oxidized to chlorine molecule, and it will lose one electron. Here the E naught cell, there is 1.36 volts, and 2H2O can be oxidized to oxygen O2 plus 4H plus 4 electron, and here the E naught cell is 1.23 volts. So these two reactions can happen, but here the lower value of E naught is preferred at the anode. So now the rule is that the reaction at the anode, the reaction at the anode with lower value, with lower value of E naught is more preferred, is more preferred, and so H2O should be oxidized to O2. H2O should be oxidized to O2 in, instead of chloride ion to be oxidized to Cl2. Instead of Cl minus to be oxidized to Cl2. So it, it means that the second reaction is more preferable. But here there is one exception. But here the exception is that um, in the second reaction, in the second reaction, although although it is more preferable, although it is more preferable, mm, but since oxygen is formed here, but since oxygen is formed, so it causes an over potential of oxygen. So it causes over potential, over potential of oxygen. Hence, the first reaction will be more preferred. Hence, the oxidation, hence the oxidation of the chloride ion is more preferred. So hence the first reaction will only happen. So option A is the correct answer. Then here it is told the charge required for the reduction of 1 mole of MnO4 minus ion to MnO2 is. So MnO4 minus ion is reduced to MnO2, since why here the oxidation state of manganese, oxygen state of manganese Mn is 4 to the 8, 8 minus 1, that is plus 7, and here the oxidation state of manganese Mn is plus 4 here. So here the MnO4 minus ion will gain 3 electrons to form MnO2. That means that 1 mole of MnO4 minus ion requires 3 moles of electrons, 3 moles of electrons, or 3 Faraday charge. So 3 Faraday charge is the required. So option B is the correct answer. Then it is told at a particular temperature, the ratio of At a particular temperature, the ratio of the molar conductance to the specific conductance of 0.01 m- m- molar NaCl solution is. So the molar conductance lambda m, that is equals to the specific conductance K into 1000 divided by m. So the molar conductance, which is ohm per ohm centimeter square per mole, that is that divided by the specific conductance, which is in per ohm per centimeter, that will be equal to 1000 by m, where m is the molarity of the solution. Molarity of the solution. So that will be 1000 by 0.01 centimeter cube per mole. Centimeter cube per mole. So that will be equal to 10 power 5 centimeter cube per mole. So option A is the correct answer. Then here it is told for a cell involving two electron changes, E naught cell. So two electron changes, it means n is equal to 2. It means the number of the electron transferred is 2. Now E naught cell is 0.3 volts at 25 degree Celsius. Then the equilibrium constant of the reaction is the equilibrium constant. The equilibrium constant of the reaction is the equilibrium constant of the reaction is equilibrium constant is equilibrium constant, this K that has been asked. So as you know that E naught cell, that is equals to delta G. So it is equal to delta G naught, which is equal to minus NF E naught cell, that is equals to again minus 2.303 minus 2.303 RT log K. So therefore we can say E naught cell, that is equal to 2.303 RT by NF log K. So now therefore you can say E naught cell, that is 0.3, that is equal to now 2.303 RT by F, 2.303 RT by F at uh, at the room temperature, means at 25 degrees Celsius. The value of 2.303 RT by F is approximately 0.059. So this will be equal to 0.059 divided by n. N is 2 into log K. So therefore log K, that is equal to 0.6 by 0.059. Now this also we can write, which is approximately equal to, this is 600 by 59, or I can take 60 also. So it is approximately equal to 10. So therefore K will be equal to 10 power 10 approximately. So it means the equilibrium constant of the reaction is 10 power 10. So option D is the correct answer. Then here it is told 1 liter of MgCl2 solution, 1 liter of MgCl2 solution, 1 liter, that is electrolyzed completely by passing a current of 1 ampere for 16 minute and 6 and 5 seconds. So the time t is 16 minute 5 second, or I can tell 16 into 60 plus 5 seconds, this much seconds. So 16 6 are 96. So in 965 seconds. So the time is 965 seconds. Then the original concentration of MgCl2 solution was. So now the weight, the weight of m- magnesium, the weight of Mg that is deposited at the cathode, the weight of magnesium that will be deposited at the cathode, that is equal to W, which is equal to Z into I into T, and where Z is equal to the equivalent weight of magnesium divided by the valency factor. No, no. Divided by 1 Faraday charge. Divided by 1 Faraday charge. Now, 1 Faraday charge means 96500 coulombs, and the equivalent weight of magnesium, that is equal to the molar mass of magnesium, molar mass of magnesium divided by the valency factor of m- magnesium. Now Mg2 plus ions will gain 2 electrons to form Mg atoms, and in this way only Mg atoms will be deposited at the cathode. So at the cathode, magnesium ions will be reduced to magnesium atoms. So therefore the valency factor for magnesium is 2. So therefore the equivalent weight of magnesium is the molar mass of magnesium, which is 24 gram divided by 2, that is equal to 12 gram. So now therefore Z will be equal to the equivalent weight of magnesium, that is 12 by 96500. Now therefore the weight of magnesium that is deposited at the cathode, that will be equal to 12 by 96500 into I is 1 ampere into T, that is 965. So this much coulomb. So 965 into 100 is 96500. So 12 by 100, which is 0.12 gram. So 0.12 gram of magnesium will be deposited at the cathode. So therefore the original concentration, therefore now the original concentration of MgCl2, that is equal to, now from here we can say that 1 mole of Mg is there in 1 mole of MgCl2. From 1 mole of MgCl2 I will get 1 mole of Mg only. So therefore I can say that the number of moles of Mg, that will be same as the number of moles of MgCl2 also. So now therefore we can say the concentration of MgCl2 is the number of moles of MgCl2 by the volume of the solution in liters. Now the volume of the solution is 1 liter only, and the number of moles of MgCl2 is same as the number of moles of Mg divided by 1 liter. So the number of moles of Mg is 0.12 gram of Mg is deposited at the cathode. So 0.12 by the molar mass of Mg is 24 divided by 1. So this much molar is the concentration of MgCl2. So this will be 12 by 24 into 10 power minus 2 molar. So it is half. 12 to the 24. So half is 0.5, or I can say 5 into 10 power minus 3 molar. So 5 into 10 power minus 3 molar is the original concentration of MgCl2. So option A is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCT exam on the chapter electrochemistry. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also please install our Sapience education application, where we shall upload some important homework questions based on the previous year KCT exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.